So please welcome one among us, the local for vocal, the one who has been part of all Laracons as an attendee, speaking for the first time on stage, our own, the local boy, Chirag on stage. Chirag bhai, energy dance kiya ho. Dance, dance, dance. Boom, 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 come karo.
Good morning.
Good morning.
I cannot hear much noise from this end. Good morning.
Good morning.
Yeah. Laracon is well known for its own energy, right? Now, if you are saying good morning with this low level energy, this is not acceptable. So one more time. Good morning.
Good morning.
Yeah. Okay. So today my topic is all about like how we can integrate vectorized database in our Laravel application. I know some of you guys have already been doing it, but still I think this is going to be a hot topic throughout the year, because it's been a kind of trend that moreover the people are going to build the large scale application. Like they are going to have their own initial startup point, but eventually they are going to scale up their system, right? So this is my belief that at some point you will require like scale up your database as well, right? And in my view, if we are going ahead with the vectorized database, then it is going to make a much more difference in terms of the performance, in terms of the user preferences, in terms of the like how the user is able to navigate to the system, how the data is getting retrieved in a much more faster manner. So that's all I'm gonna cover up today. So let's take it start. I hope I am audible till end. Please raise your hands. Thank you. Okay. This is a small intro about me. So my name is Chirag Daxini, and I have been sharing the stage for the very first time at Laracon. I have been there in local meetups, or at least around, if I don't forget, then it has been there like around 4 to 5 times. I have been there as a speaker, and after that I got a chance to be here to share a stage with all of the precious members, the community creators, the platform creators, and I have been associated with an organization as a technical project manager. I am handling a team over there. I have started my journey being as a coding data developer. I took a training over there, and then eventually I reached to the next step. When I started my journey, it was Laravel version 5.x. So from there, I have been connected with Laravel, and overall, I am holding 11 plus of experience. Initial phase, if I talk about my initial phase, and literally you all will be able to relate with the same as well. So let's get into 10 years back time. So let's say when we stuck in any situation or any problem, right? The ultimate helping hand for us is only the Stack Overflow. You guys are agree with that?
Yes.
Nice. Now we have lots of support from AI, so thankful to the creators of all of them. And right now, like as I say, right now it's quite easier to debug the things with the help of AI to come up with a different solution based upon the aspects, based upon the context, and based upon the solution that is going to be exactly be fitted in our application. And what I love, I love to explore more and more things and more power of the community, because Laravel community is quite huge, I can say. Not limited to the India, but outside of the India. And if you are stuck in any situation or any problem, just we have to raise the question, and I am pretty much sure that you guys are going to have the response for that. So all thanks to the community, and let's go to the next thing. Okay. So why vector database matters in the modern application? Let me give you an example. Initially, take a step back like 5 years or something beyond that as well. If we have a listing, okay, and we have a table, and if you wanted to search for something specific, like that basically the table consists of, let's say, like 1 million records, and if I wanted to search anything out of it, right, then if I was going to search with my name, let's say my name is Chirag, and I wanted to get my record out of it, right? So it is definitely going to do that, but on top of that, if I wanted to see the relevance record, let's say like my name or whoever others are having name in their email address, I'm giving you a very rough example. So if I wanted to do that, then I will have to separate out the things. Like initially my focus is onto the name, then my focus is going to be onto the emails as well. So I have to combine these things together, so that we can see the exact result out of it. Now, when it comes to the vectorized database, it is going to give us a flexibility to define all this type of semantic cells. So here I have given you a very rough differentiation between like how the traditional keyword search is going to look alike and how the semantic search with the vector is going to look alike. So here you can see that exact string matching only is going to be possible, limited context awareness. That means whenever you are searching it out, right? I'm talking about the traditional part at the moment. Whenever you are giving the context to the search, so it is only going to remember what exactly you have given the context for that. But when it comes to the vectorized database, it is also going to remember the things, and whenever you are going to search for the very next time, it is going to come up with that that context as well. Poor relevance for similar concepts and fails with the synonyms and variations. That's a very good example that I have given you about the name and the email. And when it comes to the vectorized, it finds the similar concept naturally and handles the synonyms and the variations very easily. So, understanding the vectors and the embedding. So, what are the embeddings? So basically, it is just like the way we shown in yesterday's demo of Taylor Auto. Like whenever he is searching or he is doing anything out of it, the embedding is getting created. So basically, embedding is a numerical representation of the text, images, or data in a multi-dimensional space where the similar items clusters together. What is the practical nodes? So practical nodes are basically like a dense numerical vectors, geometric, similarity model dependency, whether it's been an open head, hugging face, or a local. Next is the semantic clustering, related concept, but it is automatically grouping together in a vector space, enabling retrieval and ranking things. Next one is the dimensity. So vector size is range from 384 to 3072. And example that has been provided, like example is the OpenAI is coming up with 1536 and the similar metric. Use closing distance as a standard measure and 0 identical to 1 opposite. So this is just again coming up with a practical comparison between the vector database and the traditional database. So you will find when it comes to the traditional database, let's take one by one. So when it comes to the primary index, it is applying the B-tree or a hashing mechanism behind the scene, right? When it comes to the vectorized, it is using or it is relying on the AN, and that is approximate nearest neighbor. Next one is the query type. So when it comes to the traditional database, it is exactly going to depend on exact matches. We will be having a way to do the matching mechanism, but still it is going to rely or it is going to depend on what exactly it has been provided in terms of the context. When it comes to the vectorized database, right? So it is going to not only follow or the similarity search, but it is also going to make a semantic matching as well. Next one is the latency. Latency, that means whenever you are querying, whenever you are, let's say, triggering an HTTP request, right? So So in what amount of time you are getting the data, that is basically called the latency. And when it comes to the traditional database, it is going to take milliseconds for exact queries. But when it comes to the vectorized database, it will be less than what it's going to be a part of a milliseconds. What are the traditional use cases for traditional database as well as the vectorized database? So for traditional, it's going to be the normal CRUD operation, create, read, update, delete, transaction based and reporting. When it comes to the vectorized database, right? With the, let's say you have a database of 100 million records. Then out of, like if you wanted to search anything out of it, right? Then it will become quite tedious, quite complex to maintain the the fastest response retrieval time. So that time the vector database comes into the picture. What are the different tools that we can rely to go ahead with the vectorized database and the traditional? I know for traditional database you guys are pretty much aware, like MySQL is there, and Postgres is there, and then Oracle is there. When it comes to the vectorized database, we have at least 3 options. Pinecone has been there, which is one of my favorite. Vivid has been there, and Milverse has been there. So how the Laravel supports the vector integration. So these are the different steps that is being associated with each of the tools. So let's say if you are going ahead with the Postgres SQL, right? Then native vector supports the Postgres SQL 11 plus that integrates with Laracon India and no external service will be required. Next one is if you are doing with the like Postgres with Laravel, then Laracon native or PG vector supports with the query builder for vector operation inside the Laravel. Then the next one is operational advantages. So migration and seedings for embeddings, queue jobs for batch generation. So these are the like basic advantages for relying on this type of tools. Scout has been there, and the second one, last one is the Melisearch integration. So modern search engine offering combine full text vector search for semantic queries. How you can integrate. So basically, these are the 4 steps that I have defined it over here. Data ingestion. So Laravel model and event triggers embedding generation using queuing of jobs for async processing to avoid blocking requests. Like if something is blocking, while you are executing more and more batches or jobs behind the scene, right? And sometimes it's going to be a issue that due to some third-party integration, some of the things are blocking us, and it's in a block state at the moment. But if we are going ahead and if we have implemented the vectorized database in an appropriate manner, then we will be having the flexibility to define any blockage. And if we have done that properly, then though the blockage is going to be there, then still our application is be in at least working state for something. So this is first step is all about the data ingestion. Next one is the embedding services. So we need to define the service layer calls. That will be like one of OpenAI, Hugging Face, or local models. Once these services are getting utilized, it is pretty much required that we'll need to cache it. So that if someone is, let's say, searching for the same type of parameter, right, then it is not going to make it another call, rather than it is going to retrieve the result in a much more faster manner with the use of the caching. And it is ultimately going to make an effect on the overall cost as well. Third one is the storage, like store embeddings in the vector database like PG vector, Pinecone, Vivid, or Milverse, and synchronizing with the source data via model runs. And this, the last step would be retrieval and the ranking. So we'll need to query the interface to get the similar to get the results out of whatever the context that has been provided. So these are the 4 minimum steps that I have defined it over here. Now, how this embedding generation is going to work out over here. So these are the again few steps that I have mentioned. So first we'll need to define which model is going to be appropriate for my application. For someone, it's going to be like OpenAI text embedding, if overall things are getting related to the text-based things. If something is related to like face recognition or have to deal with the image generation and anything like that, then we have to define something else. Local as well is going to work as well. Then the batch processing. Then we need to generate the embeddings for bulk data like product catalog to maximize the throughput and lower the per item cost. That means like whenever we have a huge number of products right in our system, then it is always recommended to generate the things in an appropriate manner so that it is ultimately going to make an impact on the cost. If it is not being implemented properly, then ultimately you will have to bear the higher cost as well. Real-time generation, whenever you are dealing with these things, queues or jobs, anything like that, then it is going to come up with a new content, which is going to generate the embeddings over the demand with a lower latency. That means like whenever you are querying something, if new data comes out of it, right, then it is going to generate the embeddings for all those new data, and according to that, it is going to revert back the results accordingly, and that is going to happen with a lower latency. Incremental updates. So we need to recompute the embeddings only for the modified content rather than modifying everything altogether to avoid full reprocessing. Caching, as I said, it's always essential to have the caching mechanism implemented in place. Then next one is the cost optimization. So reuse the embeddings for the similar content, batch API calls, monitor tokens, and implement rate limiting. So the cost and the caching, I can say these are more interrelevant because if you have caching mechanism is not in place, right, then day by day your cost is going to be bigger and bigger. Next one is the deployment trade-offs. So balancing the OpenAI products, production readiness, Hugging Face, low latency and self-hosted cost, Olama privacy and GPU needs. So these are the things that will come into the picture when you are dealing with the like production data. Next one is the semantic search for e-commerce, like boost relevance and conversation. So let's say you would like to integrate the vector as a database for your e-commerce application, right? So how you can do that? So these are the very simple steps that I have written over here. Embedding the product data. At the first place, we need to generate the embeddings for all the products that's been there. And here I have defined a very basic information about each of the products, like name, description, and attributes. And that is going to be stored into our database for faster retrieval time. Then embedding the queries. So whenever customer is going to search for any particular text, that embedding is going to get matched for this semantic matching up. And then as a next step, it is also going to take into consideration about the similarity search. Like the way I've given you the example that if you are searching, there has been a table, and let's consider that you have not implemented data tables. Now you would like to search by your name, and there are other people who are also there who is having a similar name as you as well, right? So, but that one is into the email. So your name is there in your name, and another person is also having your name into the email, but not into the name. Now, if you have defined or if you have developed the logic for defining that particular query based upon your name, then the another person is not going to be there into the listing, because there you have defined the overall logic for name column only, right? So with the vectorized database, it is giving us flexibility to perform the similarity search as well. Let's say like returning top 20 running shoes ranked by the relevance, and then rank and filter. So apply business logic, price range. So let's say you have come up with a listing. Now you would like to filter out the results by different parameters. Then that can be done with a very lowest latency. Real world use case that I have written, like what it comes up with a content recommendation engine. So how does it look like? content ingestion, that's similar to generating the embeddings for all your, whether it is your product or listing or whatever it is. Then embedding, similarity query, signal blending. So whenever you are querying the vector, right, for the nearest item by embedding the similarity at a recommendation time. Signal blending, blend content similarity, popularity and recency to produce the candidate list, ranking and A/B test. So whenever your result is going to be up your search result actually, then it requires to be displayed in a ranked manner. So that's something you will also be able to perform or give a proper context to the database. Hybrid approach, content-based, similar content for new user. Like if, for an example, if I am a user and I came to the platform for the very first time, then for me it's going to be a different user. But when you guys are performing and you are like a frequent user on the platform, then it's going to be a different thing for you as well. How does it is impacting our business? So overall, the control will be like 35%. These are the like statistics that I have defined. How like this is more over from the user friendliness perspective. Like let me give an example. If you have built up a website and I have, that's basically an e-commerce based application, and you like I've been landed onto the homepage, and after that I've been navigating to the product listing page or a category page, and there it is taking nearly about 8 to 10 seconds, right? And for me, it's a worst experience because nowadays everywhere the AI is in trending, everything, every tools are available, and if we haven't the mechanism in place, then we want to be able to see the conversion rate. So ultimately, if you have better control over the system, then the user is going to stay more on your platform. That means there are high chances that that user will get converted into your customer. So basically that's all about the business impact. So how this AI-powered customer support with Vector is going to work? So there are again 6 types are there. The first one is the embed query and the FAQ. So whenever as a first place we just have to create the vector embeddings for a customer questions and FAQ entries to enable the semantic matching. Next one would be the semantic retrieval based upon the context or based upon the embedding that we have stored into our database. It is going to come up with the semantic retrieval process as well. Next one, the context assembly. So collect the retrieved document or a crash log if like while querying the database something is not working, or let's say you ended up with an error, then you will be able to see that as well. And conversation embeddings to build the context. Next step would be LLM synthesis, like pass your assembled context to the LLM so that it can generate a precise and concise contextual response for your customer or for your user. Response delivery, return an instant answer to customer and log resolution outcome. That means like whenever the result is going to be presented to the user, there can be a chances that for some customer it can be different, for me it's going to be different, for you guys it will be different, right? So we can also log the resolution time as well. And down the line we can, based upon that frequency, we'll also be able to scale it up so that the user will get the output instantly. Learning loop. Again, this 6th step is all about starting from first point, then following all the points till point number 5. Track first response, resolution, response time, and satisfaction to update the knowledge base. So you have to keep monitoring all the steps, okay, and then at the end you will be having a very good mechanism in place. Next one is the Laravel and a vector database practical integrations. Like what are the different packages, what are the trade-offs, and when to choose each of the platforms. So on the left hand side, in the very first column, I have defined the package. The second one is type, integration, and for what context this particular package is going to be best used. So if we say start with the Laravel Scout, so obviously is providing abstraction on the search mechanism, integration multiple backends via drivers, and for what purpose it is being used best for. So if you wanted to do like full text-based search or like vector search, that is going to be useful best. If you have been relying on to the Postgres, right, then pgvector has been a kind of ORM extension. Integration wise, if you're going to see that, then the Postgres SQL native has been there, and if for what platform it is being best for, if you have integrated your system or any Laravel application with the Postgres database, then this will be the best alternative for that. Millisearch is basically a kind of search engine. It's just been relying on providing the dedicated services. And if you are running the things onto the production, probably then this will be the best match for that. Next one is the Pinecone, which is one of my favorite, as I said earlier. So basically, it's a kind of VectorDB client. What is behind this? And it is integrating. So basically, it is integrating the rest of gRPC API. And for what purpose it is being used for as a best practice. So if you have managed or if you have like vectorized database, then this will be the best option for that. And Vivian client, last one is if you have so Pinecone and the Vivian client is both are a VectorDB client, but the way of integration in both the platforms has been a different one. So on Pinecone, as I said, it has been relying on to the REST API. But when it comes to the Vivian, it has been depending on not only onto the REST API but as well as onto the GraphQL. Pinecone is best for managed hosting, managed vector-based services, and Vivian is being appropriate for self-hosted flexibility. Now, how can you choose like which vector database is going to write for me? So these are the 6 steps that I have defined. By having a knowledge of all these steps, we will be able to figure out like which vector database is going to be useful for my application. So what is your like as a first place, it's been a scale requirement on what level you would like to scale up your application. So this is going to be a number 1 step. Small scale under like 1 million vectors, probably the PG vector or Miller's self-hosted is going to be enough. However, if your application has been large scale over like 100 million vectors, then Pinecone or Vivian is going to be useful. There has been a like costing as well defined. So Pinecone is going to cost you around like 0.25 per 1 million vectors. So that's not that much of costly, but this will become costly if we haven't cashed out the things properly. Latency requirements, again, if it has been like 100 milliseconds, then Pinecone or Vivian is going to be best for managing this thing. If you are wishing like you would like to give the results within a 500 milliseconds, then probably the PG vector or self-hosted Miller's will be helpful. And next one is the operational complexity. Like you would like to go ahead with the very minimal DevOps related things, then Pinecone is fully managed. You will be having a full control over it. When it comes to the Miller's or Vivian, it is going to be self-hosted. You will have to invest some of your time into that. And Postgres is coming up with a native option. So if you are thinking that you would just like to control the things with a very minimal option, then obviously the number 1 priority would be the Pinecone. What will be the cost model? Again, this is a very interesting thing. If your storage is about, if your number 1 priority is all about the storage, then as I say, for 1 million vectors, what is going to be charged? And if you are thinking like the costing should be calculated based upon the queries that is going to be executed on the platform, then probably Vivian is going to be well versed. And when it comes to the self-hosted, then probably you will like to go ahead with the Miller's or PG vector, which is going to incur only cost related to the infrastructure. Now, the next one is Laravel Applications. So basically, as I shown you in the one of the previous steps, that native support has been there for PG Vector with Laracon. However, if you would like to go ahead with the SDK based thing, then Pinecone and Variate has been there. However, it has still been providing the abstract layer, and you can also do the millisearch via Scout. Now, what is the recommendation? So if you are a startup, right, you have designed your platform from the MVP perspective, then probably you would like to go ahead with the PG vector. However, if you are planning to scale up your system to the next level, then obviously Pinecone is going to be used, and for privacy critical, it's going to be a self-hosted method. So these are, by following all the steps, we'll be having a good knowledge like which option I should go ahead with for my application. Common misconception and the practical consideration. So, like based upon this, we'll have faith or like beliefs that if I have the vector database in place, then it is going to handle each and everything. But there are some myths about that. So vector database are not magic. So it depends based upon the quality of data, quality of embeddings that is being there. Data preparation is been there, and whenever there will be a garbage has been there, that is going to be get out of it. Not always better than the keyword search. So vector excels at semantic, but sometimes it matches the match, the exact match. So in this case, we'll tend to rely onto the hybrid cells. So LLM still differentiate with the vector context. So sometimes the vector reduces likelihood, but do not eliminate the hallucination. Vector database will have some non-trivial cost. Again, it is more related to the costing part. If you have not cached out your embeddings or the search result in an appropriate manner, then probably you will be able to see the higher cost as well. Data privacy concern, embeddings, all of these things you need to manage in an appropriate manner to have a better user experience, and it is going to make your user into a proper customer. Next one is the production consideration. So overall, you can see like what will be the if you are processing the batch arrays, like caching up the results in a Redis, then the time to live will be, we can also define the time to live over there from like 1 hour to 24 hours. What are the tools and add-ons we can so there I have defined some of the tools like Datadog has been there, New Relic, Prometheus Plus, Grafana. So all these tools are available, which is going to give you an alerts if there will be a need for that. The security backup. These are some of the basic things that I have written to give a better of more context in terms of what are the steps that will be required for the production and performance and the scaling. Getting started, your initial. So what will be the ideal roadmap is going to look like. So as a first place for like week or two, it's going to be a foundation. You need to learn how the embedding is going to work. Then as the second step, think about the proof of concept, like if I'm going into this direction, then what will be the steps that I need to perform. Then third place will be the production preparation, where we are going to plan out for making the things and how we can load the task with a 10x load. And the fourth step will be launch and optimize. Thank you.
Okay, thank you, bro. So we'll do it real quick, rapid fire, because time is running out, everyone is hungry.
Yeah.
So let's do it right now. Bhavdeep, please come this way. I hope you must have enjoyed first time being on stage. Yeah, that I could literally feel you are like enjoying being in your space. So I have personalized rapid fire for you. Before that, just give me one moment. Can you please go and talk to Abbas? You're just changing one thing in schedule. Just go. Run. You want to make sure the momentum will remain the same. Alright? So, first, traditional DB or vector DB?
It depends, but I would like to go with vector DB.
Okay. Second, accuracy or speed?
Accuracy speed.
Third, small models or big models?
starting from small models and eventually grow up with the big models.
Perfect. Cache embeddings or recompute?
Caching.
Fifth, prototype fast or design properly?
It would be designed properly. I would
Okay.
say.
Sixth, AI features or core product features?
I would go ahead with the core product features.
Perfect. Seventh, explainable AI or magical AI?
It would be magical.
Eight, Laravel queues or real-time pipelines?
It would be real time pipeline.
Perfect. Nine, debugging AI or debugging production?
It would be debugging AI.
10th and last one, build in-house or use APIs?
Build in house.
Alright, perfect. Thank you, Chirag, for being on stage.
Thank you once again.
Thank you.
So now we are making a bit more schedule change.